Objectives for today's lesson is to derive the distance formula, find the distance between 2 points, find the coordinates of the midpoint of a line segment, and apply the distance formula, improving some geometric properties. Let us have first a recall on the Pythagorean theorem. So this theorem states that in a right triangle, the square of A, so this side, plus the square of B is equal to the square of C. We have to take note here that C is the longest side and this one is called the hypotenuse, while A and B are two other sides. So we say that A squared plus B squared equals C squared. This is the formula for the Pythagorean theorem. Try to illustrate how the Pythagorean theorem works. A 3, 4, 5 triangle has a right angle in it. So using Pythagorean theorem, we have 3, 4, 5 for A, B, and C respectively. So substituting the values of 3, 4, 5 in the formula, we have 3 squared plus 4 squared equals 5 squared. So the square of 3 is 9, and the square of 4 is 16, the square of 5 is 25. So figuratively, we have the square of 3, which is 9, plus the square of 4, which is 16. It is equal to the square of 5, which is 25. Let us have this example. Let us find the missing side. What is the length of the missing side? So using the Pythagorean theorem, we know that the longest side is the hypotenuse or the C. So we have the formula A squared plus B squared equals C squared. So substituting the value of 5 for A and 7 for B, we have 5 squared plus 7 squared equals C squared. The square of 5 is 25. The square of 7 is 49 equals C squared. And then we add 25 plus 49, we have 74 equals C squared. So solving for C, we get the square root of both sides. So we have, what is the square root of 74? Correct. So the square root of 74 is approximately 8.60. Let us derive the distance formula. So let us calculate the distance between AB. So to do that, we assign a value or coordinate for A. So for coordinate of A, we have x sub 1, y sub 1, while the coordinates of B, we have x sub 2, y sub 2. Using the Pythagorean theorem, we know that this side is the longest side or the hypotenuse. So we place AB as our C and line segment AC as our A and line segment BC as B. So substituting it to the formula C squared equals A squared plus B squared, we have now AB squared equals AC squared plus BC squared. So since we are deriving the distance between AB, we get the square root of both sides. So the equation now will become AB equals square root of AC squared plus BC squared. Now, we know that AC is the horizontal distance. So we just need to subtract the coordinates, the value of the coordinates of x. So for the horizontal distance, which is AC, we just get the absolute value of x sub 2 minus x sub 1. While for the vertical distance, which is BC, we just need to get the difference between the y coordinates. So we have y sub 2 minus y sub 1. Now, knowing that AC is now this value and BC is this one, we just substitute it to this equation so that we can obtain AB equals the square root of the distance between AC, which is x sub 2 minus x sub 1 squared, and the distance between BC, which is y sub 2 minus y sub 1 squared. So we have now our distance formula, which is AB equals the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. So we just need to substitute or find what is x sub 2, what is x sub 1, what is y sub 2, and what is y sub 1. So knowing that our A and B has the coordinates of negative 1, 0 and 2, 7, it means that the value of x sub 1 is negative 1, value of y sub 1 is 0, value of x sub 2 is 2, and the value of y sub 2 is 7. Substituting these values to this formula, we have AB equals the square root of 2 minus negative 1 quantity squared plus 7 minus 0 quantity squared. Simplifying, what is inside the parentheses, we have 2 plus 1 then, so we have 3, and 7 minus 0, which is 7, and then we get their squares. We square 3, which is 9, and the square of 7, which is 49. And then we add them. 9 plus 49 is square root of 58. Now we obtain the square root of 58. So we have approximately 7.62. So it means that the distance between AB is approximately 7.62. Let's have another example. So let us find the distance between points A, B. So for A, we have the coordinates 3, negative 7, and B has 6, 2. So in this case, we have x sub 1, which is 3, y sub 1, which is negative 7, x sub 2 is 6, and y sub 2 is 2. Substituting these values to the formula, we have AB equals the square root of 6 minus 3 quantity squared plus 2 minus negative 7 quantity squared. Simplifying, we have 6 minus 3, which is 3, and 2 plus 7, which is 9. So the square of 3 is 9, and the square of 9 is 81. So add 9 plus 81. So AB here has square root of 90. So AB, simplifying, we have 3 square root of 10, or it is approximately 9.49. Example. The distance between the points 3, negative 7 and negative 2y is 13 units. What are the possible values for y? So for the solution, we will be using the distance formula, and let us identify what is x sub 1, which is 3, y sub 1, which is negative 7, x sub 2 is negative 2, and y sub 2 is y. So substituting these values to the formula, we have 13. 13 here is the distance between these points equals the square root of the quantity negative 2 minus 3 squared plus the quantity y minus negative 7 quantity squared. Simplifying what is inside the parentheses, we have 13 equals the square root of negative 5 squared plus the quantity y plus 7 squared. So the next step is we are going to get the square of both sides. So how do we do that? We square both sides. So the next line then will become, so the square of 13, which is 169, and the square of the square root of 25 plus the quantity y plus 7 squared is now, so we will be canceling this out. So it means that the next line will become 169 equals, 169 is the square of 13 equals 25 plus y plus 7 quantity squared. Now, we simplify, so we join 169 and 25 to the left side of the equation. So the next line will become 144 equals the quantity y plus 7 squared. Okay? So, simplifying or applying the reflexive property of equality first. So, we need to get the square root of both sides. So, we get the square root of both sides. So, this one now will be cancelled. What will be left is the square root of 144 is positive negative 12. So the next line will become y plus 7 equals positive negative 12. So it means here that we need to equate y plus 7 to both positive 12 and negative 12. So for y plus 7 equals 12, we have y equals 12 minus 7. So the value of y here is 5. For y plus 7 equals negative 12, we have y equals negative 12 minus 7. So the value of y here is negative 19. So it means that the possible values for y are 5 and negative 19. So for our next objective is we find the coordinates of the midpoint of this line segment. So to obtain that, let us find the coordinates of the midpoint M. So we have to assign here the point A is having the coordinates of x sub 1, y sub 1. For B, having the coordinates of x sub 2, y sub 2. Knowing that these are the endpoints of the line segment AB, and point M is the midpoint. Then we can obtain the coordinates of the midpoint by adding x sub 1 plus x sub 2 over 2. And for the coordinates of y coordinates of the midpoint, we have x sub 1 plus y sub 2 over 2. So what would be the solution? So in here, for the point A, x sub 1 is 3, y sub 1 is negative 7. For point B, x sub 2 is 6, y sub 2 is positive 2. So we will just substitute these values to the formula. So we have 3 plus 6 over 2. And then for the y, we have negative 7 plus 2 over 2. So simplifying, we have 3 plus 6, which is 9 over 2. Negative 7 plus 2, which is negative 5 over 2. So in expressing this in decimals, we have 9 over 2, which is 4.5. And negative 5 over 2 in decimals is negative 2.5. So it means that the coordinates of the midpoint of line segment AB is 4.5, negative 2.5. Now let us try to prove some geometric properties using distance formula. So let us define first what is a coordinate proof. It is a proof that uses figures on a coordinate plane to prove geometric properties. So it means that if we are trying to prove geometric properties with the use of the coordinate plane or the x and y axis, it means that one is called the coordinate proof. So for example, given this figure, let us prove that the diagonals of a rectangle are congruent using the methods of coordinate geometry. So given that the rectangle ABCD with diagonals AC and BD, let us prove that AC and BD are congruent with each other. So in proving some geometric properties using methods of coordinate geometry, we need to consider the following guidelines. So the first guideline is we must use the origin as vertex or center of a figure. The next one is we need to place at least one side of a polygon on an axis. And if possible, we have to keep the figure within the first quadrant. And we have to use the coordinates that make computations simple and easy. This would mean that sometimes using coordinates that are multiples of 2 would make the computation easier. Now let's start proving. So for the first step, we have to place the rectangle ABCD on a coordinate plane. So this one. So following the guidelines, we have placed our vertex of the figure on the origin, and we also place at least one side of the polygon on an axis. So in this case, we have placed side AB on y-axis and side AD on x-axis. And then we need to label the coordinates. So how do we do that? So this is now the label of the coordinates. So for A, we have 0, 0. For B, we have 0, B. For C, we have AB. And for D, we have A0. So we need to find first what is the distance between AC. Knowing that the coordinates of A is 0, 0 and the coordinates of C is AB, we will substitute these values to the distance formula. So we now have AC equals the square root of the quantity A minus 0 squared plus B minus 0 squared. So simplifying, we have, so the distance of AC is equal to the square root of A squared plus B squared. So we're done proving the distance of AC. Now, let us find the distance between B and D. So given that the coordinates of B is 0, B, and the coordinates of D is A0, so substituting these values to the distance formula, we have the distance of BD equals the square root of A minus 0 squared plus B minus 0 squared. Simplifying, the distance of BD is the square root of A squared plus B squared. So what have you observed? That AC, both AC and BD, are equal to the square root of A squared plus B squared. So since AC is equal to the square root of A squared plus B squared, same is true with BD. We can then say, by substitution, that AC is equal to BD. So therefore, we can say that AC, line segment AC, and line segment BD are congruent to each other. So therefore, the diagonals of a rectangle are congruent. Let us deal with another example. The median to the hypotenuse of a right triangle is half the hypotenuse. So given triangle ACB, wherein the right angle is on ABC and D is the midpoint of AC, let us prove that DB, which is the median to hypotenuse, is equal to 1/2 of the measure of AC. So, how do we do that? So, what is the first thing to be done? So, considering the guidelines for placing figures on the coordinate plane, so we have placed or used the origin here as the vertex of the figure, and we also place at least one side of the polygon on an axis. So let us now try to name the coordinates. So these are the coordinates. For B, having the coordinates of 0, 0. For point A, we have 0, B. For point D, we have A over 2, B over 2. And for point C, we have A0. So for the solution, let us find first the distance between BD or DB. So the distance of DB, of course, can be found using the distance formula. So DB is equal to the square root of the quantity A over 2 minus 0 squared plus the quantity B over 2 minus 0 squared. Simplifying, we have DB equals the square root of A squared over 4 plus B squared over 4. Now, combining them on the same denominator, so we have 4 as the perfect square. So the next line will be dB equals the square root of A squared plus B squared all over 2. Now, let us try to find the distance between AC, or this hypotenuse. So the distance of AC is equal to, knowing that the coordinates of A is 0, B, and coordinates of C is A0, it means that we can use this as substituted value. So we have AC equals the square root of quantity 0 minus A squared plus quantity B minus 0 squared. Simplifying, we have AC equals the square root of A squared plus B squared. Since we are getting half of AC, so we have to divide both sides of the equation by 2. So then we can obtain half of AC is 1 half AC, and half of the square root of A squared plus B squared is equal to the square root of A squared plus B squared over 2. So we have noticed here that dB and 1 half AC, they are both equal to the square root of A squared plus B squared over 2. So we can then say that dB is equal to 1 half of AC. Or it is a proof that the median to hypotenuse, which is the line segment dB, is half of the hypotenuse. It's really half of the AC. Now try doing this on your own. Until our next session, thank you and enjoy learning.